First thing we need to do is look at and work on number 112 a little bit more. That was from last class. It's where we started talking about solving quadratics and talked about a few methods, including quadratic formula, but we didn't get too deep into that. So we are going to work on that a bit more together. Then we'll look at the top half of the handout you picked up on your way in, number 113. And then I'll give you time to finish both of these up. And then at that point, you guys should be caught up with my 8A classes. Okay, so just quick reminder, this unit is a mix between linear stuff that we have already gone over, quadratics, which we're right in the middle of right now, and we'll do a little bit more focus on piecewise functions before we get to your next test. So again, that's a pretty short unit, but we're over halfway with it. Okay, so you guys will have to tell me, because each of my classes are in slightly different spots. I believe last class I talked about 4 different methods, and then you practice one of each on the front page. We did all of that together. Is that correct? Okay. On the next page, to work messier quadratic formula questions, we need to review simplifying radicals. So I did 9 through 16 with you. I believe you already did 17 through 20. Is that correct? It is? Okay. Did I have you check those yet? No? Okay. All right, so give me 30 seconds here, and I'm going to do these quickly, so there's a good chance I might have a mistake, but we can go over any of them in detail that you need to. But I think this one should be 3 square roots of 2, 3 square roots of 5. Oh, my bad. 5 square roots of 3. Again, I'm just doing it real quick in my head, so. This one should be 4 square roots of 5. And 2 square roots of 21. Did those sound correct? Okay.
Okay. We were talking about concurrent classes.
Who is it?
Miss Norman.
Okay. Okay, and then I also had you try, was it 26, 27, 28? You already have those completed? And we didn't check those. Okay, so let me share those 3 answers. I would get 2i squared root of 7. Uh, 6i square root of 2. Is that right? Okay, thank you.
I got a different answer on that one.
Okay, what'd you get?
3i square root of 8.
Okay, let's work this one in a second.
That's the same thing.
Yes, square root of 4, square root of 2. Yep, it's square root of 2, and you get 6.
Yes, it's the same thing, just less than
5i square root of 6. Okay, you got to tell me. I'm sorry, I don't remember here. This one I got
3i square root of
3i square root of
8.
8. Okay, well that's not fully reduced, wherever that one came from, because square root of 8 breaks down into 2 square roots of 2. So you really should have brought out an extra 2. I don't know if that's what you said or not, but I would go with 6i square root of 2. Okay, so that leaves a couple more that I would like you to come back and practice, but let's not worry about that right now. Let's go to the next page. So this is where we're going to focus on quadratic formula, but we're going to start off with the nicest, cleanest that it's going to be with 29. Then 31 is a little bit messier, and then 35 is a little bit messier. 33 is kind of out of place, so we're going to cross that one off. We don't need to do that one. So I'm going to do easiest version possible, 29, then a little messier 31, a little messier 35. Then I will give you a few minutes to try those as well. 30 is going to be on par with 29, 32 is on par with 32, and 34 and 36 are on par with 35. Okay, so again, I'm focused on quadratic formula here. If I just wanted to solve this, honestly, I would just use factoring. And by the way, on the test, we will probably say, you know, work this with quadratic formula. But that doesn't mean that out to the side, you couldn't also solve it with factoring. So, as a way to check. But to work quadratic formula, you need to identify what A, B, and C are. So everything needs to be on one side before you pick off A, B, and C. So that will not be true on the back page, so I will warn you about that before I have you do those. I don't really consider that a step though. I really consider the first step to make sure you have quadratic formula memorized correctly. So by the time we get to your test, you better make sure you remember that one. Plug in the numbers as it says. So opposite of B, plus or minus, square root, B squared. Now, you guys should know what negative 10 squared is. Negative 10 times negative 10 is 100. I do want to very briefly say, a lot of times I see this error in a calculator though. Sometimes you guys double check that by doing this, and that's not what you mean. That's why your calculator is giving a different number there. Your calculator does order of operations very strictly, so it does exponents before multiplication, and that's why it thinks it's that. What you mean, again, I hope you're not plugging this in the calculator, but what you mean is the second one. All of B is being squared, the negative as well. Okay, minus 4AC over 2A. So honestly, once you have the quadratic formula memorized, there's not a whole lot of thought to get to this point. But this is where you need to slow down just a bit and be a little careful. 2 times 1 is pretty hard to mess up, but the discriminant, the stuff under the square root, is about 99%, 95% of the mistakes that I see when we get to the tests and I'm grading tests and stuff. You need to be extra careful here. This is like 100 plus 44. Now on the back page, they might be messy enough that you might need a calculator, but at least try it first without a calculator. Okay, now the reason I said that this is as nice as quadratic formula is going to get is because it depends on the determinant. The determinant determines what your answers look like and how hard it's going to be. 144 is a perfect square. That comes out to be exactly 12. So that just makes the end of the question pretty nice and neat. One answer comes from 10 plus 12 over 2, and another answer comes from 10 minus 12 over 2. So, best case scenario, just like question 29, is your discriminant's a perfect square. So, in a few minutes, 30 should work out just as cleanly. All right, with 31, this one is not going to be a perfect square, but quadratic formula is still going to be just fine. So I already know quadratic formula, so I don't really need to write it down every single time, but I would highly suggest you to force yourself to write it down every question. That repetition will help you memorize it correctly. Okay, so I'm going to do what it says. Opposite of B, plus or minus, B squared, minus 4 times A times C, all over 2 times A. Very little mental processing should be going on there. I'm just doing what the formula says. Denominator, 2 times 5 is obviously going to be 10. But the discriminant, please slow down and double, triple check. Let's see, this would be 25 times 4 would be 100. 1 minus 100 would be negative 99. And of course, negative 99 is not a perfect square, and that's the only thing that's making this harder or messier than question 29. So, based on the last page, we know to bring out the negative as an I, and then break down 99 into 3 square roots of 11, and then you're finished. That doesn't simplify more. It's kind of messy looking, and I'm going to talk about how you can check your answers for the back page when we get there. Even an answer like this, you can be 100% sure that's correct when you have a calculator. Okay, so again, 29 as easy as possible because the discriminant's a perfect square. 31, a little bit more work because the discriminant was not a perfect square, but if you can simplify a radical, you can still finish. Okay, on to the hardest. And it's really just one extra step. It's not that big of a deal. But you still started off the same way. There's nothing obviously different about this question. Negative b plus or minus b squared minus 4ac over 2a. Denominator is 2. Discriminant is 4 minus 28, which is negative 24. Again, I'm highlighting that step every time because that's where most of the mistakes are going to happen for you. So that's where you need to put more focus. Now it looks like the last question. Obviously you can bring out the negative as an I, and I would recommend you do that before you forget about it. And then the square root of 24 is like 2 square root of 6. But unlike the last question, there's still one more step that needs to be done here. And I don't think you guys practiced this a ton in Algebra 2. It looks more complicated, but we really just need to reduce our fraction. You wouldn't leave an answer 2 over 4 because this is divisible by 2 and this is divisible by 2. You would divide them both by 2 and change it to a half. Well, the same thing is happening here. Negative 2, 2i square roots of 6, and 2 are all evenly divisible by 2. So you should divide everything by 2 to reduce your fraction. Divide by 2, divide by 2, divide by 2. Now when you divide 2i square roots of 6 in half, that leaves you 1i square root of 6. The I square root of 6 is what it is. I just have half as many of them. But you don't also divide the 6 by 2. Now, one other thing I'll kind of point out here, because this might make it a little easier for you to see. This is how I think of it. If every term's divisible by something, you need to divide it by that. But remember, you can also split apart your fraction. You could put negative 2 over 2, as long as you're willing to put 2i squared of 6 over 2. And if that makes more sense to you, splitting apart your fraction, reducing this one, and then reducing this one, then that also works. So whatever way just makes more sense to you. But you need to make that part of your check at the end. Make sure that your fraction's reduced. Yeah?
Whenever you're taking out the negative and you have the I, do you put the I after the number or before?
Like if this was like 7.
So it says 2i right there, like on the left.
Uh-huh.
Could you put the I before that or after? Or
You can, because technically this is just multiplication. 2 times I is going to be the same as I times 2. But most people put the numbers first, so that's just, but it's not wrong if you put the I first. What would be a problem is even though this is 2 times I times the square root of 6 and the order doesn't really matter, in a textbook they always put the square root of 6 last, and you probably should do that too, because if you do this it's hard to tell if you think 2, is this a 2 or is this a square root of 2? And that's where you run into problems. So I would leave the square root last, but the rest doesn't really matter. And of course, even if you made it like super obvious, like this or something, then that's fine. But usually you guys don't do that. Usually if you put the square root first, you make it kind of iffy on if it's a 2 or a square root of 2, and then I can't keep that. So, all right, so take a minute or a few minutes. Should take you about 8 minutes roughly, but go back to question 30. 30 should be on par with 29. The discriminant should be a perfect square. It should work out about the same amount of steps. Then try 32, where the discriminant's not a perfect square and you just need to reduce the radical, like number 31. And then try 34 and 36. Those should work out like number 35, where the discriminant is not a perfect square, your radical reduces, but then based on how your radical reduces, your fraction also reduces. So again, I'll give you a touch more than 8 minutes to try those 4 questions. So try to finish up that page. I will share those answers and I can go over all of them if you need me to, or we can talk about the ones you need me to. I'll give you some hints from the last page, but then we will jump over to the other page, to today's handout. And again, I think you should have plenty of time at the end of class to finish up the few questions we're not going to do together on this one, and the bottom half of today's handout that you'll be doing on your own. So shouldn't have any homework from that part. Johnny, you finally got a question right?
Yes, precisely.
Had to happen eventually.
I know, you're right. I have enough wrong problems. Got one.
Okay, I'm happy to go over any or all of these, but let's first just compare work and compare answers and try to eliminate. So number 30, the discriminant was 16, and in the end you should have ended up with answers of 3 and 7. So again, there's a good chance on the test that you'll have a question or two that says solve this with quadratic formula, but that doesn't mean you couldn't also factor it out to the side. I think factoring would be a good way for you to see the answer should be 7 and 3 as a check. Everybody okay with all this part of number 30 before I move it up? Okay, then 32, the discriminant was 18, and that's the only reason it's a little more work. 18 simplifies to 3 square roots of 2. So your two answers were -4 plus 3 square root of 2 over -2, and -4 minus 3 square root of 2 over -2. Now notice, this one does not reduce more, even though you should have thought about it. 2 or -2, 4 or -4, and 3 square roots of 2. Those are not evenly divisible by the same number. You can't just reduce this part of it unless you split up your fraction. If you split up your fraction, you could, but you can't just let 4 divide by 2 and then pretend like 3 square root of 2 is not over 2. Okay, is there any part of 32 you would like to ask about? Okay, and then to the most amount of work would be 34. Discriminant was 8, which changes to 2 square roots of 2. But then at the end, notice I have circled in red, -4, 2 square roots of 2, and 4 are all evenly divisible by 2. So you have to do that last step. Stopping here, even though this is technically equivalent to it, it's not a reduced fraction, so you couldn't get full points for that. And then same difficulty, 36. I'll leave them both up at the same time. That discriminant wasn't too bad. -4, square root of -4 is 2i, but again, notice the last step. That's what's different about this section. 3, 2i, and 10 are all evenly divisible by 2, so you need to do that to reduce your fraction. 3 plus I over 5 and 3 minus I over 5 are your two answers. Okay, is there any parts of 34 or 36 you'd like me to go over? Okay, I'm going to come back to 36 in just a second, but one thing you need to be careful about, we're going to move on to the other handout in just a second, but something that did not come up on any of these until the back page, and again I'm going to ask you to do the back page today, but if you say that A is -9, B is -10, and C is -7, you can plug those numbers in the quadratic formula if you want to, but it's not going to come out to be the right thing. You can't identify A, B, and C until it's in standard position. So move everything to the left or everything to the right, just whatever you prefer. And then, once everything's on one side, then you can identify A as being the coefficient of x squared, B being the coefficient of x, and C being the constant, but not before. So I'm pointing that out just because it didn't show up in the first 3 pages, and you need to do that on the last 6. Secondly, I want to make sure that you know that your answers are correct on these last 6 So there is a way for you to check these with the calculator. Now again, you probably won't get a calculator on the test, but even if your answer, this is where I'm going to go back to this one, even if your answer is imaginary, like we got in number 36, your calculator can tell you if this is correct or not. So the way I would do that is I would store one of the answers in 3 plus I over 5. Now, it's not this I. This I is for when you're typing a message. You're good. It's this I down here that's a number. If you hit second decimal, it knows you're talking about the number I over 5. This was the last question we looked at from the other page. Now, I would like to store that in for X. That's just easier than typing it in multiple times. But your calculator can even do this part for you, the imaginary part. And if that was actually correct, it's supposed to make this original problem equal to 0. That's what it means to solve a quadratic. So then you can ask your calculator, what is 5x squared minus 6x plus 2? 5x squared minus 6x plus 2. And it's supposed to be equal to what?
0.
So even though the answer was imaginary, your calculator can still check it and make sure that it's correct. Even though the answer doesn't look right, it doesn't look familiar, it's not a nice whole number. Hopefully in Algebra 2, you learned that imaginary zeros always come in conjugate pairs, but if you didn't, it doesn't take you but another 10 seconds to check the other version too. So your calculator doesn't let you do plus and minus, but you could do plus and check it and minus and check it, and then that's how I would like you to check the last 6 answers. You don't have to just hope that you did it correctly. You should know if you did it correctly with the calculator. Okay, so again, I'll give you some time to finish that up where you shouldn't need to do any of that for homework, but let's go over to today's handout, and we need to talk about the graph analysis. So graphing a quadratic, we need to review how to find the intercepts and what a vertex is and how to find it, and what's a line of symmetry, and what's the graph going to look like, what's different ways to write it, etc., etc. Now again, all of this is stuff that should sound familiar, but I realize that you're probably pretty rusty on some of this. Of course, you should try to add some notes and give yourself some help. But I'm going to do the top half of this for you, and then the bottom half is the exact same questions, it's just a different function on the bottom half. So I will ask you to do that one. And then most of this you can check by graphing this in the calculator. Just make sure you're not doing that to get the answer. Okay, so first off, this says write in vertex form. I'm going to come back to that. I think that's one of the things that you probably need the most review on. But I'm trying to pick off stuff that I feel like most of you can probably check off as things you remember. So factored form is just like its name implies. Just take the standard form and factor it. So better if you notice there's a GCF. You should always factor out a GCF first if possible. And then of course I hope that you get it with guess and check factoring, but if you have to do product sum or some other method that takes you a minute or two, that's fine too. You need to be able to factor it to get it in factored form. I feel like that's pretty straightforward, so I'm not going to dwell on that too much, but as always I will let you ask questions at the end. Okay, I don't think y-intercept is one that you should be too concerned about. Y-intercepts, just like every other thing we've done this year, always have an x value of 0. So if you plug 0 into the function and solve, y would be negative 12. Nothing uniquely special you have to memorize there. Now for the vertex, the vertex is a point. The vertex is either going to be a max or a min. It's the tallest point at the top or the point at the bottom, depending on which way the parabola is opening. But for the x value of the vertex, there's actually a formula that you can use, and there's a second way to get this that I'm going to tell you before we're done with this. But the x value can be found by negative b over 2a, which for us would be 2 over 4, or 1/2. Okay, so now I've got 2 trivia questions for you. One is, why does this sound familiar? Why does negative b over 2a sound familiar?
Quadratic formula.
Right, the quadratic formula, it's just the left part of the quadratic formula. That's where you kind of already have it memorized. You just have to make that connection. Second trivia question, even though this one should be a given for everybody, I know it's not. How do I find that? Say what? Right, the same way I did part C. If you know the x value you want, you plug it into the function and solve for y. Now, of course, 1/2 is a little messier, so I'm just going to let my calculator do that real quick. But anytime you need a point, you plug the x value into the function and solve for y. Again, that's one of the first algebra things you ever learned. But again, I will show you a second way to find the x value of the vertex before this is over. Okay, to know if the vertex is a max or a min, you really need to know if this parabola is opening up or down. So if A is positive, A is this number, it's going to open up just like x squared. This is positive x squared, A is positive 1, it opens up. If it opens up, the vertex is at the bottom, which makes the vertex a minimum value. Whereas if A was negative, it gets flipped over the x-axis at some point, and the vertex would be a maximum. But for this question, it's a minimum. Again, you should probably add this to your work unless you are dead sure that you remembered that before I said it. Now, if you want to know what the maximum value is, or the minimum value, well, that's right here. That's what the vertex is telling you. It's telling you when it occurs and what its value is. This guy goes down as far as negative 12.5. The line of symmetry is going to be a vertical line, and it's going to be a vertical line that cuts your graph in half. So if my parabola looked like this, the line of symmetry goes through here. If my parabola looked like this, the line of symmetry is going to be right here. Either way, you need to recognize that it has the same x value of the vertex. So getting the vertex is really the legwork for finding the line of symmetry also. Okay, and then x-intercepts are when y equals 0, and to me, I would just use the factored form. That's where factored form is going to shine. Standard form has benefits, vertex form has benefits, and factored form has benefits. Since x-intercepts occur when y is 0, if you already have it factored, you just set each factor equal to 0 and solve. 2 never equals 0, so that doesn't give me 1. X minus 3 equals 0 at 3, and x plus 2 equals 0 at negative 2. So usually if you just want the x-intercepts, you're just going to deal with factoring. Although you could do quadratic formula if you'd rather. You would still get the same answers. Okay, so again, factored form is great for x-intercepts. I think this standard form is a little bit better for y-intercepts. But if you want an equation that you can look at and see what the vertex is going to be, if there's something special about the vertex in the context of the problem, you probably want to write it in vertex form. So vertex form looks like this. And there's 3 numbers we have to replace. A, H, and K are supposed to be numbers. Okay, well, H, comma, K is the vertex. So the x value of the vertex is 1/2, so this is supposed to say x minus 1/2 squared. Don't forget the square. If you don't put the square, it's not a quadratic anymore. K is supposed to be the y value of the vertex. This says plus k, so plus a negative 12.5. Now this is kind of uncomfortable for people sometimes because these signs look backwards. you're subtracting the x value of the vertex, but then adding the y value of the vertex. So if you wanted the vertex from the equation, it's actually the opposite of this, positive 1/2, and then not opposite of this, negative 12.5. So that's how it's supposed to be. Just be careful with that. All right, what would you guess A to be?
A, 1, 2.
Y, okay, it is 2. But was that a guess or an educated guess?
Educated.
Okay.
From the quadratic formula.
Right, and that's why they used the letter A here. It's the same A as quadratic formula. That would be not consistent and wouldn't make a lot of sense to use A if it represented something different. They would use a different variable like D or something. That where you wouldn't get that mixed up. A is the same A from the quadratic formula. So that's how you come up with vertex form. And again, its benefit is I could tell you the parabola opens up because A is positive. I could tell you the vertex is at 1/2, negative 12.5 without seeing the graph. I know how far the graph goes down. I know where the line of symmetry would be, x equals 1/2. I can tell you a lot about the graph just by the equation in vertex form. Okay, so now if we throw this stuff together to make a graph, the smallest point is at negative 12.5. So I'm going to put my x-axis up a little bit higher. I'm not going to center it perfectly. But we can go through and start to plot all these points. We've got a y-intercept at negative 12. Vertex at 1/2, negative 12.5. We've got x-intercepts at 3 and negative 2. All right, now here's third trivia question. This says 5 points. I see 1, 2, 3, 4 points. So why are they saying 5 points?
Possibly plug in something.
Okay, yeah, you could always plug in more points, that's true. But there's one point in particular that should be pretty quick.
The 12th point, but on the other side of the vertex.
Okay, so good. So this line of symmetry, you don't have to graph the line of symmetry, but if you do, just make sure you put it in as a dashed line. This is supposed to be the line that cuts your overall shape directly in half. So notice this point flipped over would land here. This point is on the line of symmetry, so you can't really flip it over. But this point could flip over, and then here's point number 5. Just from the symmetry, that point should be an automatic. Okay, I said I would give you a second way to find the x value of the vertex, and here's the other way that you can do this besides the negative b over 2a. If you can find the x-intercepts, negative 2 and 3, the x value of the vertex has to be in the middle of those. So if you just average the x-intercepts, add them together and divide by 2, you get the middle of the x-intercepts, which is also where the x value of the vertex should be. So if you prefer that instead of the negative b over 2a, it's just an option. But all right, to finish this up, increasing, decreasing, and constant. So these are really big calculus concepts, but increasing just means where's the graph. Oops, I need to connect these. Where's the graph going up? So that's not how far down does it go, not how far up does it go, but when is it increasing? And the when implies x values. He starts increasing when x is 1/2, and he increases forever to the right. Decreasing is a way to describe when the graph's going down. Again, when, so that's x values, starts going down all the way to the left, and he keeps going down till you get to x is 1/2. And then constant is where your graph is flat for a moment of time. Quadratics don't have a constant section. They're either going up or down to the vertex, and then they're doing the opposite after the vertex. Now again, in a perfect world, you remember all of that, but very likely you need to identify a couple of these things that you remember that, or feel like you don't remember. So I think for most people that might be vertex form. Maybe it's finding the x value of the vertex. I don't know. Everybody's going to be slightly different there. So I'm going to leave this part up for now to make sure that you get everything you need out of that. So to finish up class today, you guys have 55 minutes, so you have almost an hour, and I need you to try one more of these, the bottom of this page, and finish up the other quadratics page. You should have 6 quadratic formula questions. Check your answers by storing in the calculator, and I think we skipped 4 simplifying radical questions. If you would please practice those, so that's finished as well. So should be, even if this is a tough topic for you, 55 minutes should be plenty of time to do that in class. So, and then you guys will be caught back up with my A-Day class. I don't know how we got behind a little bit, but we did. So, obviously, I'm happy to help. The bottom of this page, I would say the best way to check that would be with a calculator. So, don't use a calculator to graph it and get the answers from, but answer the questions and then graph it in the calculator. And if the vertex is in the right spot and the x-intercepts are in the right spot and the y-intercepts in the right spot, then it's probably in good shape. So, but just let me know when and where I can help.